Hi guys, welcome back to the channel, and this is the second session of Java programming class. And in this video we will cover some theory portion which is related to the OOPS concept. And in next video we will cover how to start writing program and what is the public static void main means. So let's start object oriented programming. First, object oriented programming is at the core of Java. In fact, all Java programs are to at least some extent object oriented. OOPS is so integral to Java that is the best to understand its basic principles before you begin writing even simple Java program. We have four principles, which is first is abstraction, second is encapsulations, third one is inheritance, and polymorphism. First start with abstraction. So an essential element of object oriented programming is abstraction. Humans manage complexity through abstraction. For example, people do not think of a car as a set of tens of thousands of individual parts. They think of it as a well-defined object with its own unique behavior. This abstraction allows people to use a car to drive to the grocery store without being overwhelmed by the complexity of the parts that form the car. They can ignore the details of how the and braking system work. Instead, they are free to utilize the object as a whole. Now, what is encapsulation? Encapsulation is the mechanism that binds together code and the data it manipulates and keeps both safe from outside interference and misuse. One way to think about encapsulation is a protective wrapper that prevents the code and data from being arbitrarily accessed by other code defined outside the wrapper. Access to the code and data inside the wrapper is tightly controlled through a well-defined interface. In Java, the basic of encapsulation is the class. Although the class will be examined in great detail later in the future videos, the following brief discussion will be helpful now. A class defines the structure and behavior that will be stored by a set of objects. Now, thus, a class is a logical construct. An object has physical reality. When you create a class, you will specify the code and data that constitute that class. Collectively, these elements are called members of the class. Specifically, the data defined by the class are referred to as member variables or instance variable. The code that operates on that data is referred to as member methods or just methods. Now come to the next one, which is inheritance. Inheritance is the process by which one object acquires the properties of another object. This is important because it supports the concept of hierarchical classification. If you wanted to describe a more specific class of animals such as mammals, they would have more specific attributes such as type of teeth and mammary glands. This is known as a subclass of animals, where animals are referred to as mammals superclass. Since mammals are simply more precisely specified animals, they inherit all the attributes from animals. A deeply inherited subclass inherits all of the attributes from each of its ancestors in the class hierarchy. This is the class hierarchy where animal is a parent class and there are two child class, which is mammal and reptile. Again, two child class, which is canine and feline, is inherit the property of parent class, which is mammal, and mammal is also inheriting the property from parent class is animal. So canine is inheriting the property of animal as well as the mammal, and so on. Now the next one is polymorphism. So the polymorphism is a feature that allows one interface to be used for a general class of actions. The specific action is determined by the exact nature of the situation. Consider a stack which is a Last in first out. You might have a program that requires three types of stacks. One stack is used for integer values, one for floating point values, and one for characters. The algorithm that implements each stack is the same, even though the data being stored differs. In a non-object oriented language, you would be required to create three different sets of stacks routines with each set using different names. However, because of polymorphism in Java, you can specify a general set of stacks and it is all share the same name. Now what is the inheritance, which is this is second slide, which is inherits the process by which one object acquires the properties of another object. This is important because it supports the concept of hierarchical classification. If you wanted to describe a more specific class of animals such as mammals, they would have more specific attributes such as type of teeth and mammary gland. This is known as subclass of animals, where animals are referred to as mammal superclass. Since mammals are simply more precisely specified animal, they inherit all the attributes from animals. A deeply inherited subclass inherits all of the attributes from each of its ancestors in the class hierarchy. So guys, this is all about OOPS concept, and this is the brief description I have provided you. And in next video and in next future videos, I will describe you these concept in detail with the help of examples. So you just click on subscribe button and bell icon. In next video I will tell you the concept of man method. So thank you for watching.